Hey folks, my name is Bailey Hayes, and we're here for our monthly community stream for June. We're going to dig into two different projects within the Bytecode Alliance because they've landed some pretty cool new features, experimental support, and landed for the first time, so it's really exciting to talk about. But first, order of business, I wanted to mention that our SIG dynamic languages special interest group has been renamed from dynamic languages to guest languages. And so if you want to find the repository for that, it's under this, and it's chaired by Kyle Brown from Single Store and Guy Bedford from Fastly. This is a name to adjust sort of the scope that's changed a little bit for this group because we're finding that a lot of the different guest languages that we're adding implementations for, they have a lot of the same types of problems that they need to solve, so they're working on that under the same banner. Now, for the other project that we're going to be talking about is about WASMTime v10, and one of the core maintainers, Fastly engineer Pat Hickey, is here with me. Hey, Pat, how's it going?
Hi. Yep. First time on a stream.
It's pretty cool. We're just gonna hang out. We're gonna talk through basically two key projects. The first one is WASMTime. It's hit version 10. It was released, I want to say, 7 days ago ish. And one of the key features that Pat's going to talk about is about the WASI Preview 2 implementations that have landed within WASMTime. One cool thing that I saw right before we kicked off the stream is that we had 30 different authors, so 30 different unique folks that were working on making contributions to the WASMTime repo. That's 114 commits, and I was kind of blown away by just how many lines of code are showing up in that project. And in order from the first top four until I ran out of time, this is Alex Crichton from Fermion is our top contributor, then Pat Hickey, who's on the stream, Trevor Elliott from Fastly, and then Afonso Bordado. So thank you everyone for your contributions. I think it's pretty incredible how many different people are involved and how many different people depend on WASMTime. The other project that we're going to talk to a little bit is the WASM Tools repo. So that is sort of a lower level tool. Pat can speak a little bit more about it, but basically you can install Cargo, install WASM Tools, and you get a whole bunch of stuff like validator, parser. There's a lot more to it, but a lot of the work here is enabling some of the component model and WASI Preview 2 work. And some of the things that happened over the past month that I wanted to highlight is work from Ivan from VMware for adding garbage collection for WebAssembly. So that's part of the core WebAssembly specification. And so that work is really great. I know Nick Fitzgerald is somebody else who's partnered with working on that. And then Timmy, I know, has partnered with Dan Goman on implementing resources and handles prototype for WIT. And then also Joe from Microsoft, he's been working on the include syntax. Last month, Joe showed off a demo of that working, and then he's been putting in a ton of different contributions within WASM Tools. And then, of course, Alex here has been doing a ton of work as well. So 10 different authors. I can't highlight everybody's work, but I feel like it's a really great group of folks that have been making really good contributions. So I'm going to stop there. Those are the two projects we're digging in on within the Bytecode Alliance. And Pat, I figure I'm going to take notes while you talk over here, but if you want to share what you've been working on.
Yeah. So I'm going to hit my screen share button, right?
Yeah.
Sorry, I rearrange my stuff. Okay. Folks can see that. Cool.
Yeah, it looks pretty good.
That's a good font size. Okay. So I made a quick demo of some of the stuff that's been going on with the host implementation of WASI Preview 2. So WASI Preview 2 is built on top of the component model, so we can use all of our WIT types to describe system resources. And in the original WASI, it was just something like, oh, we can make a command application, which is something that has a main that takes some string arguments, and then it returns whether it succeeded or not, right? Returned an integer. The WIT tooling is, of course, a lot more expressive than that. So we have in the WIT tooling here something that's, I just call it test.wit. I stole this right out of some test infrastructure we have in the WasmTime repo to make this demo.
Actually, Pat, do you mind increasing your screen, just the font size a little bit? Thank you. That looks good.
So this is a WIT file. And you can say that this is defining a world called test reactor. And I'm calling it a reactor because reactor is the word we have for something that is, the opposite, or the thing that is not a command. A command is something that it's a command line interface thing. It gets instantiated, it gets passed some string arguments, it gets run, and then it's thrown away. A reactor is a lot more interesting than that. A reactor is kind of like an object that you have method calls on. These export functions are something that stick around. Like the state of the reactor is contained in the WASM store, and you can call these functions as many times as you want. So there's a whole bunch of imports available to this world. So I'm just stealing all of these from WASI, right? This is saying the WASI CLI base, which this gives you environment variables. You have a type for IO streams available to this reactor. Pre-opens and file system are a way of giving files to it. It could also call exit if it needs to. Those are all things that we're expecting those to be available in basically all of these WASI worlds, right? And the exception there is there might be some worlds that don't have a file system, and we have this story for how you'll actually add a component that provides you a virtual file system.
Hey, Pat, do you mind describing a little bit more about what you mean about WASI worlds?
Oh, okay. Yeah, I'm getting ahead of myself. Okay, so a WASI world is a description of an environment that can run, a WebAssembly component world. So worlds are a component model concept. WASI is just a set of interfaces. So worlds are basically the environment in which a program runs. So that means there are imports available to your program or to your component, and your component is expected to provide certain exports. So a much simpler world is, oh, I wasn't prepared for that, so I'm not going to try to show you a different one. This world is saying that, okay, I have these interfaces, which are defined in, this is a package name. WASI is a package namespace. CLI base is a package name, and environment is an interface name. So it's like all of these interfaces are available to this program, to this component as imports. And then these exports are saying this component is expected to export the following functions. So I made a function called add strings, which if you give me a list of strings, I'll stick them in somewhere. I'll stick them in my state somewhere, and I'll tell you how many strings there are. And then get strings is like a way of, show me all the strings you've accumulated in that state. And then we have another piece of this, which is, a use statement is basically saying I can use a particular type from another interface. So the WASI namespace IO package, there's an interface called streams, and streams has a type named output stream. And I'm going to use that output stream. I'm going to pass into my I'm going to pass as the argument to this function. I'm like, here's an output stream. I would like you to write all of your strings to this output stream. And then result here is a way of saying, oh, you can succeed or you can fail. And then another demo was, the file system has output stream is a resource type, right? It's an object which you have an opaque reference to. The index, the reference right now is a table index. It's a U32. Now, a file system interface has this thing called a descriptor stat. And a descriptor stat is if if I go to deps, file system, the descriptor stat is this record that tells you all things about a file descriptor, right? It's got all of these different fields of device inode, descriptor type, timestamps. And so this was just a demo of like, oh, you can reuse these types that we defined in these interfaces in other interfaces, in other worlds. So this is the whole deal is like, the reason to have a WASI standard is not just to implement these CLI programs, but it's this whole ecosystem of types, whether that's resource types like output stream or just structs like descriptor stat or timestamp or whatever. We can use those throughout this ecosystem, and we all know like, oh, we're all talking about the same thing. It's a common type system. So that's a bit more of this world. Bailey, did I do a good job, or did I skip over things that are obvious to me because I don't think about
That was so good. I took notes. I'm totally using that next time I talk about it. I think that really explained it. The way that I think about reactors is that they're kind of like libraries that I can embed in programs, and that's pretty great.
Yeah.
The other cool thing, I guess, is that when I look at things that you have, like these imports that you enumerated, if they're part of the WASI namespace, they're basically standardized APIs, as you said. So standard, basically language that everybody can speak now, of types and interfaces. But I guess the other thing I would highlight there is that a lot of times, if you see an import for WASI, that's probably something that maybe is provided to you by your runtime. Is that about right?
Yes and no. So obviously, I'm creating a host runtime implementation of WASI. That's what's in WASMtime. Starting in Preview 10, we have this experimental version of it. I can give you all the caveats of why it's experimental, but I'm going to set that aside for now. So yes, like there is a host implementation that provides, like here is how WASI works in WASMtime. And that is done in terms of the host operating system. So it's like when I'm exposing a file system, that's just like in WASMtime with WASI Preview 1. It's like, oh, if you want to map a certain directory on your host file system to a certain directory in your guest, or just say I'm going to mount /temp as /temp or whatever, you can do that. Like that's the way you mount host resources. The killer feature of the component model is that it's not just that it's provided by the host. In WASI Preview 1, that was the case. You could only implement WASI in the host because you didn't have the component model yet. You didn't have all these features of composition. With Preview 2, because we're on the component model, you can implement this file system interface in a component. So you can make a component that conforms to, or that has essentially just, export WASI file system /file system, export WASI CLI-based preopens, export WASI CLI-based environment. And it's like, cool. Now, if you take any component that has an import of those, you can compose that with this component that provides an export of those. And then you have a self-contained component that it no longer needs an import of the environment variables or preopens or file systems. Those are provided exclusively by WebAssembly code. And so this is really cool because it allows you to do things like, I don't need to know if the host has like the ability to say, mount my blob storage in the cloud bucket as a file system. I can have a component that knows how to import the WASI HTTP interface, and my host does provide me a way to do HTTP requests. And it can export the file system interface. And basically, it's like anytime I'm using the file system, it's WebAssembly code that's actually going out and using my blob storage for me. And so suddenly I can ship that code anywhere that runs WebAssembly and just provides HTTP. I don't need that to be built into a host and be special. Like it's suddenly it's portable. I can, if the code out there doesn't meet my requirements, I can build my own. I can customize it. I can do things like, I can tell it where to keep my secret keys to go to my blob storage, and it gets that from some future development of the WASI crypto interface. WASI crypto is not quite on the component model yet, but we're working on it. So we can do all kinds of things like that, where it's and that's the other really cool part of this code is like it's this hypothetical yet, but we are working on it. Blob storage to file system WebAssembly. You don't have to trust that code is implemented correctly, because it's sandboxed as WebAssembly. And that's really important for people like me. So I work at Fastly, and our whole deal with WebAssembly is we provide it on our edge to our customers, and our customers use it to host really big websites that do lots and lots of requests per second. I can't have one of those customers say like, oh, well, I need to access blob storage as a file system, which is a real thing our customers ask for. So we can't say, oh, okay, well, we'll build in the code that works just for your case, and we'll send it out to the edge on our host, right? And then the minute you find a crash in that code or a way, that crashes our entire edge, right? So when we build it into the host functionality, there's a much higher level of trust, and it has a much higher level of impact if something goes wrong in that code. If you wrote it and you had an unwrap in there, that causes the whole process to panic. If we keep it in WebAssembly as a component, it means that it's sandboxed, so if something goes wrong in there, it just traps that particular component. So it's just your one execution that dies, and you can just ship new WebAssembly to replace it. So that's like the big motivator for us at Fastly to care about this, because this is important to the service we provide. But I think the reason we care about the component model more broadly is because we think lots of people have this problem and this need, and this is going to solve problems for a lot of people.
So I guess to summarize, components are composable, virtualizable, and extremely adaptable. I've always heard the composable and virtualizable aspect, and I've talked to Luke before with the term that he coined, virtual platform layering, and we just dove super deep in what it means if you can virtualize everything, anything and everything. And that's really what you were talking about being able to plug in and supply some of these WASI imports with another component. But the third one, I think, just makes so much sense to me in that it's extremely adaptable. In that, if you are on a system that doesn't have a file system, so you're on an embedded device, well, you can supply that with something that's either in memory, something that offloads to a remote cache. Who says a file system actually has to be a file system? No one here in this environment. It's all up to whoever implements that interface.
Yeah, exactly.
Cool.
So yeah, I could show you an implementation of WASI file system today, but the host implementation of WASI file system, to be completely honest, it's boring. That's one thing that's kind of nice about it. I don't, exposing the host's file system to WASI is at this point easy. When we implemented this for Preview 1 years ago, we went through kind of like an initial implementation where we did all the sandboxing logic right in the WASI implementation. And then Dan had a lot of really cool insights from that. He came up with this whole library ecosystem called capstd for a capability-based Rust std library. And so we use, capstd takes care of all the file system sandboxing. And so to actually implement the file system, that you're importing here from, in this demo that I'm going to give, it's implemented in the host. It's basically just based on the underlying capstd code that we made for Preview 1. And all we had to do is adapt it from the Preview 1 way of looking at files to the Preview 2 way of looking at files, which is mostly a translation of WIT. And anytime that you're doing reads or writes, we're using these new stream primitives. I'm not going to dive into that today because it's very gritty and nerdy, and I think that has a pretty small audience. But I do think the rest of this of okay, you can use WASI in your programs, and you can make your own of these library programs that have these kind of function signatures, and that's what I want to demo today, especially how that interoperates with these WASI types. My output stream type here is the demo I really have planned. So I'm going to start showing you that. So I have over on this screen now, I have what I'm calling the guest side of the demo. Like here's the program that we're building to run inside as a component. And it's a Rust crate that's, source lib. Most of this is boilerplate. WitBindGen is taking this world, this test reactor world that happens to live out in that directory. And it generated all of the boilerplate so that's like, great, you just use a regular old Rust code. So this add strings function that's exported, here is the implementation of it. It takes some strings and it tells you that. And if you'll excuse the Rust unsafe, is I didn't clean this code up to look nicer for a demo, but essentially it's just that state is a static variable here. Rust is worried about there being multiple threads accessing the state at the same time. And WASI components at the moment, we don't have threads, so it's always safe. So I'm just mutating the state and saying, I'm going to look if you're pushing something that looks kind of like a variable, if it has a $sign leading. If it does, I'm going to look in the environment. So that's, WASI is providing environment variables to, your libc or your std or, whatever your standard library that knows about basic, POSIX things like environment variables. And it's saying, oh, okay, well, I'm going to look up that variable. And if I get a value for it, I'll push that value. And if not, I'll push the word undefined. And if it doesn't look like a variable, it just gets pushed, right? So that's what add strings does. Get strings is just spitting back out the strings that I've done already. And then write strings to output stream. So what does that look like? I say, okay, so for all those strings in my state, I'm going to put a new line on the end of each one. And then this is an import function that comes from our WitBindGen generation. So you can't see where this WASI module and IO and streams modules are generated. They're put in the program by that macro. But they're this, right? They're whatever the description of IO and streams are in this WIT, which I can open that in the depths, IO streams.wit, and it's this. What is a stream write? It's just where is write? Sorry. Output stream is U32. Write takes output stream and a list of bytes, and it tells you how many bytes there were, or it might have a stream error. And it's like, okay, so anytime I want to just write things to my stream, that's a function call on this opaque reference, right? So it's like, okay, so I'm taking my string, I'm just saying that it's bytes because streams are byte oriented. And I'm just, taking the error and turning it into whatever. So it's like, okay, so that's write strings, and then who cares about this important record? This is just to show that, we're using the WASI file system type here, and we're just gonna use it. We're gonna print it. We're gonna return the string that it's debugging. So that's what the guest program is up to. So let's look at the host then. One last bit about the guest. So I just made a shell script to build it. So right now, we have a lot of cool tooling called Cargo Component that Peter's worked on. I didn't want this to be a Cargo Component demo, so I'm cutting that. I'm not using that at the moment. So it's, how do I build this guest program? Well, I target WASM32 WASI. WASM32 WASI is, of course, WASI Snapshot Preview 1. That's the thing that's built into Rust std at the moment. And implementation detail we don't really expect users to have to care about. We've found a really nice way to paper it over. Is that WASI Preview 1 is not the component model. Like it's a different ABI. It just does things differently, not in a big fundamentally different functionality way, but it just talks to the outside world with pointers and stuff instead of the canonical ABI that uses different way to manage allocation that works in the more general case. So we have this special adapter called WASI Snapshot Preview 1.wasm. That's part of the WASM Time project. That was part of the work that we landed as part of the WASM Time 10 release. And WASM tools component new. That's WASM tools is the other project that we're going to talk about after this demo. It contains this component creator. It's basically saying I create a new component. I'll use this adapter, and that basically says take any of the function imports in this namespace, in the WASI snapshot preview 1 namespace, and use this file to resolve them. And then it's saying, passing in the output of the cargo build, and then the resulting thing is a component.wasm.
I've always thought this was really cool that once you get to an ecosystem with WASM, that you can use other WASM to do adaptions on WASM. So this is not a component model thing per se, other than it takes WASI Preview 1 and converts it to something that's WASI Preview 2 that is a component.
Yeah.
Sometimes what I do here is I to prove it to myself, I do WASM tools print, point at the old thing, which is a module at the top of the file, print the new thing, it says component at the top of the file. It's not the most exciting part of the demo. Sorry to inject here, Pat, but just to show it's a different API between the two.
Right, so WASM tools print says that's a module, and component.wasm. That's a component. And you can start to see some of the things in this component is, I'm importing the WASI CLI environment, I'm importing streams, I'm importing the clock, and so on. So, yeah. Okay, I'm going to move over to the host implementation, because that's the part that, actually to be completely honest, a lot of this guest stuff, this has been working for a little while. It's making it work with the WASI types. That's the part we're really proud of right now. So over here on the host. So this is a Rust project. I'm depending on the WASM time that's sitting in my tree right now, just because I'm using a PR that hasn't landed yet. We're going to land this as part of WASM time 11. There's just a couple of little new features that we're proud of that I'm showing off today. Otherwise, this your basic Rust project. It's using Tokyo. It's parsing whatever. So let's look at sorts main.rs. There's a lot of boilerplate at the top. This is, again, because it's a completely standalone demo. I'm not. You won't need all of this for every program. I just kind of put it all in here as part of the demo. So it's like, we're using obviously WASM time and WASM time WASI preview 2. So all of the preview 2 implementation is under this module namespace. Our intention is that when this is all ready, it will become the root namespace and the other stuff will go into legacy mode. But we're not 100% there yet. We're getting close. So we're importing a bunch of things from that library. Anything you see under this word preview 2 is coming from that library. And then, we're going to run WASM times WIT-bindgen. So WASM times WIT-bindgen is just like this WIT-bindgen out here. It's going to look at that world, and it's going to generate all the bindings that we need to make this look like nice, easy to program Rust. One thing that's, this is obviously a very short invocation that's basically just giving you the path of the world parameter. We have a bit more features in the WASM time 1. One is that, are we doing this as async Rust? And yes, this is in a Tokyo world, so I'm using async Rust instead of synchronous Rust so that I can wait on streams to provide me more input. Basically, and when this program sleeps, it's just an async yield. It doesn't actually hold the whole thread down. So that's why we're async there. And this with statement is basically just saying, anytime you're using you're fulfilling this interface, I actually have already got an implementation of it over in the WASM time WASI crate. So that's what this with is for. It's mostly just boilerplate. You don't really need to care about it that much. And this is more boilerplate of some stuff Joel's been working on lately. But So then we'll say, okay, so we've made this test reactor. I'm going to ignore this boilerplate right now. Let's just ignore it. Let's not look at it. So we've made this test reactor, and oh, look, that becomes here. This is a test reactor instantiate async. Again, there's a lot of boilerplate here of setting up WASM time, adding all the preview 2 stuff to the linker. One day this will be shorter in lines. It's just right now it's not 100% done. But the actual interesting part here is like, okay, you all remember our good friend WASI Context Builder. A WASI Context Builder back from the preview 1 days is, it's just where you stick all the things that WASI needs to know about. If you wanted to push a pre-opened directory, you would do that here. I'm not going to do that for this demo, but that's how you would like. This is just the programmatic equivalent of when you're using the WASM time CLI.
Yep.
Right, so you would, that's how that one works. So anyway, so we're just pushing some environment variables because that's what this program is looking at right here in my environment variables, right? It's because the environment is part of this world. And it's like, okay, then we're making a store. We're loading a component from the file. It's just, the component I'm building out of this. And then I'm doing an instantiate of that component with this linker, meaning here's where I'm finding all the actual implementations for my imports. And test reactor is basically just providing us a nice, easy way to call our exports. So yeah, that's just my setup function. You don't really need to think about it anymore. It's just like, okay, we'll always take the input file and set up. We'll have our store, which is where our state is, and then our reactor is our nice interface to it. And so reactor can call the functions, anything with call underscore is the prefix, and that's to make sure we don't have name collisions with like reactor : new and stuff like that. So here's how, we're going to call add strings, right? And this is nice. This is, the store is always the argument in WASM time. And then here's the actual strings. And the component model, like here, they're Rust borrowed strings. The component model will copy those strings into the guest here. And when they get to the guest, of course, they'll be owned strings because they're living in the guest's memory. So the guest actually has full ownership of those. So there's no memory safety problems here. These are distinct copies of the strings, but the component model is just totally providing that interface that copies them to and from. You don't have to go and invent all your ways of moving strings to and from a program, kind of like you had to use pointers and all that in preview 1. It's like, okay, so I'm going to add these 2 strings to the store. And, it's going to interpolate good dog. And it's like, oh, well, what was good dog? Well, I said that it was Gussie.
Is Gussie behind you?
Yeah. So Gussie.
Gussie's real tired. But also definitely a good dog.
Yeah. Okay. That's good dog. And Will is pouty dog. So we can, you know what? Host, cargo run, yes, component, .wasm, and it's just going to build it. And it says, okay, so it put those strings in. Then it called get strings, right, which is the get my state back out. Here, the return value of get strings is a vec of strings, and that turns into a vec of strings out here. Contents happens to be a vec of strings there. I can show you that still type checks. We're inserting that's equal to just a regular old slice of stir, because that's just a convenience Rust provides. Okay, so we can change that, and it just works. Right, we changed which environment variable we're interpolating. So we're just showing that, okay, this is all hooked up. The world this reactor is living in is the same one that the WASI context builder is providing. And of course, I have an assertion there because this is for tests. Okay, so I also said I had this WASI structures that I can pass in structures that are kind of this common definition of these. So let's look at that implementation. It's not that interesting. This is really just that, okay, so I said where's file system coming from? File system is, this is coming from the WASM-time WASI Preview 2 implementation. So I said here to BindGen, make sure you use all of those implementations when you generate the bindings. And so this is just showing that, I'm actually using those Rust types of this file system. I showed you a call function to the reactor that passed strings in. Well, this passed an imported record function. It takes this custom structure, this descriptor stat. So I'm going to pass in that descriptor stat. And the thing I get back out is a string, right? That was what the definition said. And I'm just going to assert that the debug implementation of the struct out here in host land matches the debug implementation here in guest land. They're two different Rust programs, but they both impl debug identically, right? Because so I've got that as part of my program now. I can comment out this print line because we don't care about that anymore. In time, but okay, but this passed. This assertion succeeded. Cool. Okay, that one's just structures. They're not very glorious, but it is important to pass them to and fro correctly. So who cares about that anymore? Let's comment that out. So my favorite is streams. I've spent the last month working on streams. So this is what I'm currently proud of. Along with help from Trevor and Alex and Joel and many other good folks, we finally cracked how to get these all working really nicely. You might remember from the WASI Preview 1 days, so I got too many things on my screen, so I'm going to make this guy smaller, that like that. So this code is so old I've been copy pasting it around that this code used to be defined in the WASI common crate. That's a lie anymore. If you remember from the WASI common crate, there was what we called write pipe. We called it write pipe in WASI common. You would always use write pipe if you don't want to inherit your host's stood out and stood error. Well, it's like, well, give me a write pipe. Give that to WASI Commons WASI context builder, right? And say, when I'm providing an implementation of stood out and stood error, actually just write it to this memory. And then later, after my execution is done, I will be able to look at that, all the things that were written there. So that's what we use, like on fastly computed edge. Write pipe is what we use to implement stood out, stood error, and all that good stuff. When in the WASM-time CLI, we just inherit your host's stood out and stood error. It's like, okay, so the version of that in Preview 2 is called a memory output pipe. The name changed a little because it needed to be a little more specific. This is, it's in the output direction, it's going into memory, and it's being used as a pipe here. So back in the WASI Preview 1 days, if I wanted to provide this stream into my WebAssembly, I would have to give it as stood out or stood error, right? Those were the only two streams we had, or stream-like things. That they were actually files. That's not important. Now they're streams. And it's like, okay, well now instead of putting them into my WASI context, I'm actually going to manipulate the table directly. This was a bit of boilerplate I didn't really dwell on, but a thing in the component model that is there needs to be one table. And what is a table? It is the thing that maps these indices. Uh, right? So an input stream here in the streams.wit is a U32. That's an index into a table, right? A table is the thing that maps that index to, oh, I actually have the object or the restruct or whatever that actually implements input stream. So that is what a table is doing in this context. The point is, it's one of those things, you have one of these per store. And you have to use the same table everywhere else in your store, or everywhere in your store consistently. That's one of the big motivators of a lot of this boilerplate. I don't want to go into it.
Would you call it state at this point for the component?
Yeah, I mean, it's part of the host state, right? The table is where the host stores any of these objects that are opaque to the component. But obviously the host needs to have a real concrete implementation of those objects. So the actual way that works in this memory stream, and you'll have to pardon me to jump to this type definition, is an output stream is anything that's a box. It's a box trait object, right? So it's something where you, the user, are allowed, the user of WASMTime and WASMTime WASI, the crates, you're allowed to impl this trait with anything you want, and you can stick it in the table. And so anytime this stream write, boy, I did not plan my monitor space well here.
It's good. It's good. I can tell what's going on.
So anytime this stream write gets called, and streams are linked to the host, it's like, it's going to dispatch to the methods in this. And what is a host output stream? I just jumped to the definition there. Well, it's a trait that has this function called write, and it has a couple other functions, and then it has this guy called ready, an async method to check write readiness. This is the crux of the whole thing, and I wish I had had enough time to prepare this demo and talk so I could really convince you why, but that is the thing I'm really proud of right now. Okay, I'm going to jump back. So in the host here, it's like, okay, I've got this thing now, this write pipe. It impls the output stream. So I'm going to stick it into my table. And the table, when I stick it in, says, oh, here's the index belonging to that thing. A way of thinking this is the table in WASI Preview 1 was just a thing that we could stick files into. We couldn't stick anything else into the table. They were just files. Now we can stick anything we want into the table, which is awesome. And this is just like when you would open a new file, be like, oh, okay, I'm going to stick that into the table, and I'm going to give you the next file descriptor. So a table index is kind of like that. It's like, here's the next index that I stuck that into. This is just a method on the table. Because it's a trait thing there, I wrote it up longhand to make it a little more obvious, because the origin of this is in tests. I like to write things longhand in tests that they're more obvious. Okay, so it's like, all right, great, cool. I've got this new table index for my output stream. Now I can call this write strings to function, right? Write strings to, and here's my output stream. It's like, great, now it has a resource that it can call methods on. Actually, I changed this implementation since last time. I bet you we even subbed in Willa there. Why don't I just print it? Right, so now we can run this. And we'll say what got written to that pipe. It's going to build my host. It's just recompiling. And okay, well, there's my string.
That gets me every time.
Yep. And yep, because streams are bytes. Consider borrowing. Thank you. Okay, and it's Hello Willa because I changed up here which dog we were passing in there. So cool. All right, great. So that's Hello Willa. Okay, memory output stream. I've demoed it. All right, memory output stream is boring because if you look, this code's all synchronous, right? Yeah, there's an await here. But like, who writes synchronous code? We're in Rust, we write async code, right? So we're going to demo how do we use output stream in a nice async way. Okay, now you'll have to excuse me. Tokyo provides a duplex pipe. They don't provide a simplex pipe or whatever. This is a bidirectional pipe. We're actually only using it in one direction. I don't know why they don't provide just the simplex version of it, or what is it? What is simplex? Is that the right word, Bailey? My brain's not working.
I'm Googling.
Doesn't matter. Ignore the word duplex here. This is just a one-directional pipe for the purposes of this demo. And I'll talk to Carl or Eliza about it sometime. So it's like, okay, so I'm going to spawn a Tokyo thing, because that's what we do in Rust, right? And I'm going to spawn a thing that takes this client, and it's just going to read bytes out of the client. You're going to have to excuse that I implemented buffering manually here for the sake of a demo, because I wrote the code about 3 minutes before we went live. And I'm just waiting for new lines. You know, if I don't have a new line, I'm just going to push it into the buffer. You know, after the new line, I'm going to clear the buffer. And also, you know, the other nice thing about Tokyo gives us here is, you know, when this with the other end of this duplex stream, simplex unidirectional stream, gets dropped, it's like, oh, the next time I read on the other end, it's going to tell me I have an EOF. You know, this is it's returning a std.io error, and you know, you can ask, this is std.io error's way of saying you've got an EOF. And so then it's like, oh, okay, I can show you whatever else was buffered, and then I can tell you the stream ended, right? So cool. So now we have an actual interactive async program that we're composing with our wasm-time execution. And this other wonderful new thing that Preview 2 Crate provides is this thing called async write stream. There's a corresponding async read stream. You can take any Tokyo async write or any Tokyo async read, and you wrap them in this struct, and it becomes a stream that WASI can talk to. So it's like, great. Well, now, you know, even though I've already pushed an output stream into my table, that's that other memory output stream, I'm just going to push a new one. I'm going to box up my pipe and stick it into the table, and then I'm going to call my write strings to again. And of course, you know, you noticed in my last demo, of course, I printed the contents out afterwards. But here I'm relying on my spawned server here, or my spawned task here, I mean, to do all that printing for me. So this is just actually going to, you know, make sure that that call was successful and exit. This is otherwise known as unwrap. It's again, I write tests weird. So yeah, let's see what happens there. Okay, so the stream read. It got a chunk of hello. It got Willa, and then it had an empty buffer when the stream ended. That's this one here. So you can see how I did all those independent writes. You know, it was buffering until a new line, but we can do one better. So we can recompile the guest to say, oh, it's actually going to sleep for an entire second between our prints. And now that we have an async stream, we'll actually be able to observe that out in the host, because we're going to get that a byte at a time. So I'm going to go back over to my guest. I'm going to build host, and I'm going to run it again. And there you go. There's your 1 second delay between hello, Willa, and the end of stream. Um, yeah, I'm. The end of stream happens when, of course, this loop ends and WebAssembly over here exits.
So that's async streams in a host?
That's async streams in the host. It's taken. It's been a long road, but we got there, and this is the foundation of doing all the not just saying hello Willa, but doing HTTP, doing sockets, all in WASI. Those are the killer features that you need. Like, I want to write, this code up here, these tasks, this async Rust code as hyper, as doing all the socket stuff, and I'm going to write that. We already have a lot of it written, and it's going to be ported to use this new version of Streams. And it's going to do it all async really well. If you look at the old WASI common implementation of how all of the scheduling of WASI actually worked, it was horrifying. I know because I wrote it all, and it's some of my least favorite code I've ever touched. Whereas this, it's like actually structured the way you would want to write async Rust code. It's extensible, and it works with the stuff that's built right into Tokyo. So yeah, I'm really proud of this. And I guess I should stop talking because I've gone really long.
I mean, we haven't gone over. We got technically 9 minutes left. And I mean, I really enjoyed it. I've gone and I've played around with some of the test code, messing around with the HTTP work that's out in WASM time. I think largely contributed by Brendan Burns there. And, all those examples are pretty tough to walk through because they just start out at like maximally complex. They have everything all together at once, and I really liked how you built up on this one. Kind of like here's the basics of sync streams, and then landing it with async streams, and it's pretty easy for me at least to look at the code that you showed and know exactly how I'd write that with hyper. So that's pretty fun.
Yeah. Thanks.
So
yeah, it's been a long road getting here, and there is an HTTP client implementation in there right now, and it implements the stream interface by waiting until the stream is completely buffered and then giving you the whole contents of the buffer at once. And it's like, technically that is a valid to the type signature implementation of stream, but of course, like actually doing the real async, feeding you a piece at a time that's coming off the request, like that's the hard part. That's the part that makes this really work at scale. So that's this is the key to making these like production worthy implementations.
Yeah, I mean, this is hugely exciting. I know that a lot of times it looks like we're, I guess, starting with the basics, but in a lot of ways, we are kind of building the fundamentals to build everything else after it. So
Yeah,
you mentioned a number of things that are coming next. I think you should probably talk through that a little.
Right. So HTTP is coming next. That is the most important thing. I mean, Fastly is an HTTP company, right? We operate in Edge Cloud, so CDN or whatever you want to call it. Our customers all speak HTTP. WASI HTTP is really awesome. We're really proud of it. It's designed a lot like the existing non-WASI Fastly proprietary HTTP implementation that we provided before the component model was ready. And the interface there was really just our prototype for this. And it did do all these, streaming bits of the body and all that, but it didn't do it in this fully generalized way where a stream is the same thing that's in file system, the same thing that's in sockets, is the same thing that's HTTP. Like, we hadn't quite gotten there yet. We just got to the point where it's like, oh, we can do it for HTTP. That's amazing. So if you look at the Fastly crate for how it gets chunks of bodies, it's like very specific to a request body or a response body or whatever.
So maybe like in your demo with the world for the test reactor, we would have an import for WASI HTTP there. And we could
Yes.
start doing some HTTP things. Might be the level up on this next.
Yes, that is the level up for this demo. Is that please stop interpolating environment variables is boring. Go out and get me something from the web. That's what we're really here to do. That's what our customers do. Is they write this code and it stitches together their website. Of this is that user's particular preferences, and this is an ad that's tailored to them, and this is something from the cache that's the same content for everyone. That's the applications that we're writing for Fastly customers to enable. And of course, at Cosmonic, you're writing that for a different set of customers who have that on a different kind of execution. So yeah, and it's the same HTTP code is going to work in all these platforms. That's what we're pumped about. We started with Fastly HTTP. It's just it's just our thing, and that was because it was we can't both get this working and ship it and do all the collaboration with all the stakeholders, because it's you can't do all those things at once. It's really, really hard. So we got it working, and then we did all the collaborating with all the different stakeholders, and we got, Joel from Fermion did a bunch of implementation on it. Radu back at Microsoft did a bunch of implementation on it. Brendan at Microsoft did a bunch of implementation on it. Bailey, you and Roman have done implementation on it from Cosmonic. There's other people who've helped with it as well, but I'm forgetting their names right now.
Tons of folks in VMware. Yeah, I mean, it feels like an alliance, right?
Yeah, Guy is working on an implementation of it. Oh, this is the other part that I gotta just be Guy Bedford type guy, because it's great, yeah, WASM-Time's an implementation of all this stuff. Yeah, but WASM-Time runs on the server. And it just runs on some servers, right? It runs on Fastly, it runs on Cosmonic, etc. JavaScript runs everywhere. JavaScript runs in the browser. That's the other really cool thing with the component model, is that all of these components we can provide JavaScript implementations for that run right in your browser, or they run in Node.js. So the WASI HTTP stuff is going to be able to be implemented in terms of fetch in your browser, the thing JavaScript already has. And that was a big part of all of this design around streams, and making streams work with the way the browsers do streams, but also other things do streams. There's a lot of a lot of complexity to get all of these platforms on common ground. But yeah, being able to take that same component and plausibly you can run it in the browser, you can run it in Node.js, you can run it on Fastly Computed Edge, you can run it in the WASM-Time CLI locally, you can run it in Docker that provides WASM-Time, you can run it on Cosmonic's services. So yeah, all those places, all the same interface. It took time, but this is what it looks like now.
This is huge. I mean, so basically this past month, first time we've landed, it's the initial implementation and it's experimental, but hey, you just showed it works.
Yeah. So, I will give the asterisk of why it's experimental real quick. Yeah. And that is that these are WASI interfaces that are not done. They are not standardized yet. We are finding slowly, it comes and goes we forgot, this has to be fallible. This has to return a result rather than just return the thing. We need to change the way that this function works. So it's we're changing we're tweaking it right now based on our actual experiments implementing it. And that's you can propose whatever standard you want. If you don't have an implementation of it that works on a couple different places, you haven't found those weird issues yet. You haven't found this really does need to be a feature on some platforms because it's not resolvable right away. So okay, stick it behind a pullable, that kind of stuff. So that's the stage we're at now. It's because we have real implementations, we can find those kind of problems. So that's why we're saying it's experimental, is we are tweaking the spec, and of course then that means it's an incompatible change to the interface, the function change signatures, based on our actual success implementing them.
Yeah, so I mean that's specifically for the WASI interfaces, right? There has also been some iteration happening on the component model and the WIT IDL.
Yes. Yeah, those have been huge as well. If you've upgraded your WASM-Time or your BindGen lately, you probably had this weird error. I had the wrong version of the tool installed earlier. You get this tool, it's oh, this is component version 2 and I need version 3, or vice versa. And that was, just semantic changes as we work out all the details of the component model. The difference between version 2 and 3 had to do with how imports work and how their naming conventions work. And that had to do with all the namespacing and stuff. It's the technical details of it are not super interesting. It was just one of those like, oh, we actually learned from having real implementations of all this in our tools. Like we needed the namespacing to work a little bit differently and support a little bit different of a way of defining your wits. So that we did have to make a breaking change there, and I'm glad we did because we have a better thing to give the users as a result.
Yeah, and I mean, I'm usually operating as sort of like your immediate end user. I'm on the cutting edge. Sometimes bleeding edge is probably a more accurate term, but I would say that I think I've seen a few interesting trends. I think a lot of the work that was happening in WIT Bindgen, just figuring out that initial iteration around WIT IDL, that a lot of that has really kind of moved into crates within WASM tools.
Yeah.
And I would say the churn there has really kind of started to stabilize. I would say it's gone from exploratory to implemented, and to now most of the changes are iterative, which is really great.
Yeah.
And then the implementation within WASM time, a ton of the work that you've done for WASI Preview 2 landing within WASM time. Same thing is that like I'm just starting to see everything kind of come together, and I feel like this month is like that. Yeah, I could put a pin in it and say like this is a point in time that is really usable.
Yeah.
I can see it. So.
Yeah, there are still a couple more things that need to come together to finalize what we're considering WASI Preview 2 and Component Model Preview 2. Those are going to be like in lockstep because you need one and the other. You need WASI to make the component model a useful ecosystem. You need the component model to make WASI possible. So we do have basically some turning resources into something where we have type safety. I can't dive into that right now because we are way over time, but that change is coming. Ownership and type safety and resources is like the last piece of the puzzle that we're gonna make to the component model. I don't know whether that's going to be a binary breaking change or not yet. I think nobody knows until we get there, but we're shaking out. Like Timmy and Dan and Alex and various other folks are shaking all that out right now. And yeah, like we've been saying, in the fall, this is going to be ready for users. If you want to use the bleeding edge now, please do. Be aware it's probably going to break. And like I said, there's a lot of boilerplate in my demos. We haven't had time to fully clean up yet, and that's okay. Yeah.
Yeah, you don't want to add abstractions too early. I mean, they leak, and that they can be their own pain to maintain. So I mean,
yeah.
Boilerplate's chill for me. Especially if you highlight, and you're like, boilerplate could be one line later.
Yeah. I'm gonna like give a shout out to the haters. There's perception online that is 100% true that like, wow, like WASI has taken a really long time to ship Preview 2. Yeah, Preview 1 was in 2019. Like, ship that thing, we didn't even know what the coronavirus was. Like, that's a while ago now. I'm not sad about that. The changes for Preview 2 are massive. The component model is a fundamentally new thing that no one's really done before. And it took us a while to get it right. If we had tried to release Preview 2 and Preview 3 and Preview 4 and all that on like a yearly cadence or even an 18-month cadence, whatever, there have been more breaking changes for our users to adjust to over this last couple years without really what I would consider to be like the real benefits of that. So we saved up our breaking change, and we're doing a big breaking change that gets you a lot of benefit. So this is like the iOS update that has the new emojis in it. Like, there's a big carrot on this one of adopting to the breaking change because the component model is awesome. It gets you a whole lot of new things. And if we had just introduced those things a little piece at a time, it would have been a fully breaking change for, well, not that much of a benefit. And we made a decision a long time ago that we weren't going to do that that wasn't in the best interest of our users. And so, yeah, that's my message.
Well, Pat, I really appreciate you. I had a blast. I really hope you come back and give us another wild demo.
Yeah, I'm going to go give these dogs a belly rub.
Yeah, I mean they deserve it. They're both good. One might be pouty, but also very much a good girl. So thank you very much. And yeah, as I guess I'll see you around on the internet. If anybody has any questions, hit us up on Zulip. So
yeah, we're on Zulip. I don't do other social media, not really. That's a lie. I did respond to a Reddit post the other day, but I regretted it immediately.
well, that was because you were like in the fall. It's WASI Preview 2. Okay, we should end on that. Great.